In this video, I'm going to show you a trick to simplify sums of complex exponentials. Now, sometimes you will see signals or functions which are a sum of two complex exponentials, but with different frequencies. And you may want to do some analysis on these signals. So for example, you may be interested in finding out when the signal crosses zeros. So what are the values of t for which x of t crosses zeros? Or you may be interested in finding how the magnitude of this function changes as a function of t. And there is a little trick that can help you simplify the solution to these kinds of problems. And to tell you how the trick works, let me give you an example. So let's take an example with omega 1 being 3 pi over 4 and omega 2 being 5 pi over 4. And you will get the main idea from the example, and then we can generalize. So in this case, x of t is e to the j 3 pi over 4 times t plus e to the j 5 pi over 4 times t. So the trick is to factor out an exponential signal whose frequency is the average of these two. So what I mean by that is, suppose I factor the average of these two exponents out. So what's the average of 3 pi over 4 and 5 pi over 4? Well, that's 4 pi over 4, right? So we have e to the j 4 pi over 4t. And notice that I can write the first term as e to the negative j pi over 4 times t. So 4 pi over 4 minus pi over 4, together it's going to give you 3 pi over 4. Similarly, this term here, think about what should go in here before I write it. So that is going to be e to the plus j pi over 4 times t. Right? And the point is, since I factored the average out, these two exponents are going to be negatives of each other. I think that's the important thing you want to think about. Okay? And why is it nice if they are negatives of each other? Well, this is of the form e to the negative j theta plus e to the j theta. And you know that Euler's formula tells us that that is equal to 2 times the cosine of pi over 4t. So this whole thing simplifies into 2 times e to the j pi times cosine pi over 4 times t. And you see that is a much nice pi t. And you see that's a much nicer signal to work with, particularly if you want to find the values of x of t for which x of t crosses zeros. For what are the values for which x of t is 0? So when is x of t equal to 0? And to solve that, you can set this to be equal to 0, and you notice that the first term never becomes 0, right? This is a complex exponential of the form e to the j pi times t. This can never go to 0 because the magnitude of this is equal to 1. And so the only way this function can go to 0 is if the cosine goes to 0. And we know that cosine goes to 0 if the argument of the cosine is either pi over 2 or 3 pi over 2, so on and so forth. Right? So what we want is pi over 4 times t to be equal to pi over 2 plus some integer multiple of pi. And that tells us that t will be 2 plus some integer multiple of 4. So when t is 2, 6, 10, negative 2, so on and so forth, this function goes to 0. How about sketching the magnitude of x of t versus t? Well, to sketch the magnitude, again, you can look at this form here, and you realize that the magnitude of this part is 1. So to compute the magnitude of x of t, so the magnitude of 2 is just 2, the magnitude of this part is always 1, and the magnitude of cosine pi over 4 times t is simply the absolute value of cosine pi over 4t. So notice that cosine pi over 4t is real, but it can be positive or negative. And since we are interested in the magnitude, that's simply going to be the absolute value of cosine 4 pi over t. And we can sketch this. It is just going to be like sketching a cosinusoid, except that the magnitude is going to be 2. So this is going to so it's just going to cross zeros every 4 apart. So it's like this. So at 0, the magnitude is going to be 2, but you can see that it's rather easy to sketch this function than try to directly sketch this function.